Hey judges, I'm Siang.
I'm Jovan.
I'm Keith.
And I'm Joyu. Together, we are the cool boys from Chongzheng Primary School.
Our project title is
The Natural Cooler.
Access to refrigeration is what we take for granted in Singapore. However, for many countries, refrigeration is not an option for keeping food cool and fresh. Our cool investigation is to explore how the use of evaporation concept to address the daily problems faced by many.
Our aim is to create an experimental setup that uses the concept of evaporation to reduce the surrounding temperature, and to find out if good and poor conductors of heat can be used to create a prototype that uses the concept of evaporation to reduce the surrounding temperature. Our hypothesis: the experimental setup that uses the concept of evaporation can help to reduce the surrounding temperature. Materials made of good and poor conductors of heat can be used to create a prototype that uses the concept of evaporation to help to reduce surrounding temperature.
We did some research and read out about an article about how a teacher in Nigeria named Muhammad Ba'aba developed and began to popularize a low-cost alternative to electric refrigerators called the Zeapot in 1995. Technique of using evaporation for cooling has already existed for thousands of years in ancient Egypt, where large clay pots were used to keep water cold.
Moving on to our first investigation. These are the materials needed for this investigation. The steps involved are creating the experimental setup and measuring the temperature inside the pot and the surrounding temperature.
Results and discussion.
The average difference in the surrounding temperature and the experimental setup is 2.5 degrees Celsius. When the chocolate that was left inside our experimental setup overnight was taken out the next morning, water droplets were found on the surface of the chocolate.
Our first conclusion: the experimental setup that uses the concept of evaporation can help to reduce surrounding temperature and hence help to keep the food slightly cooler. Our reflections.
The experimental setup that we have used in our investigation is too heavy, bulky, and not attractive for our Singapore consumers who are leading an urban lifestyle. We want to further explore how we can apply our knowledge about materials that are both good and poor conductors of heat to create a light, portable, and attractive prototype that is able to obtain the similar investigation results like our experimental setup.
Moving on to our second investigations. What improvements did we make to our experimental setup? We replaced the sand with sponges because we think that the sponges are not too messy, not too heavy when partly soaked with water. It's easier to replace, wash and wet the sponges, and water can be still evaporated from the wet sponges. Using materials that are both good and poor conductors of heat. If the outer container is made from a good conductor of heat, the whole prototype may gain heat fast from the warm surrounding. If the inner container is made from a poor conductor of heat, when the water evaporates from the wet sponges and the wet cap, the inner container will not be able to lose heat fast enough.
Now, let's look at how the natural cooler is done. These are the materials needed for the second investigation. Step 1. Put a wet cotton wool into the strainer. Now, put some sponges around the cotton wool. The sponges have to be wet. Now, put the bowl in between the sponges. Put your item you want to make it cold. And last but not least, cover the prototype with a winter cap. The cap also has to be wet. And now we're done.
Results and discussion. Analysis. The average difference in the temperature between the surrounding temperature and the temperature inside our natural cooler is 3.3 degrees Celsius. As you can see, the chocolate left inside the natural cooler has not melted and it feels cool, while on the other hand, the chocolate left in the open has melted and felt warm. Our scientific research. The temperature inside the prototype has also decreased over time. Second conclusion. The correct choice of materials made of good and poor conductors of heat can be used to create a prototype that uses the concept of evaporation to reduce the surrounding temperature. Hence, cooling effect can still take place.
So what is so good about our natural cooler? Number 1. Food stays cool and good. It is possible for us to help to solve daily life problems about keeping some of our food cool and not so easily spoiled on hot days for a short period of time without the use of refrigerator.
Number 2. Shen, save, save, big savings. You can save storage space in your refrigerator, save electricity and money, and save our Mother Earth.
Our users can also use sleep. L is for light, E is for economical, yet lasting for only $10. You can also get the materials from Daiso. A is for attractive and P is for portable.
Users find our natural cooler easy to set up, reusable and washable. An idea today, a future tomorrow. Natural Cooler will seek and explore various types of fabric and materials to get help cooling even more efficient and energy saving for a better tomorrow.
We have come to the end of our presentation. Thank you.